This video is about creating a system of linear equations. Creating a solution and having a system of equation that fits that solution. So you have to start with the solution. We're going to do one in 3 variables. You can do one in 2 variables, you can do one in 4 variables, on up to as many as you want. But we'll do one in 3 variables as a good example to start with. So we'll start with x equal to 2. We're just picking out random numbers. We're just making up our system of equations. You can pick any numbers. Any old numbers will do. But we want a system that fits the solution. So you'll see what I mean in a minute. So 5 times 2, which is the x, plus 2 times -3 minus 1 times the 4 equals 10 times -6, not times, but minus 6 minus 4 equals 0. And that is equal to 5x, the x being the 2, the 5 being the random number we picked, plus 2, and then the -3 being the y, 2y minus then 1z, z is 4, equal to 0. We just came up with one equation. And we do this with all 3 equations. We just come up with a random set of numbers. And in that way you'll create a system that fits the solution. And it can be any numbers. That's the beauty of it, and it'll always work. So we're going to pick a few more here. I'll just write them down quickly. 3 times 2 plus 4 times -3 minus 2 times 4 equals 6 minus 12 minus 8 equals -14. And this is our second equation, 3x plus 4y minus 2z equals -14. It's equation 2. Equation 3. Let's see. Let's pick -2 times 2 plus 1 times -3 plus 5 times 4 equals -4 minus 3 plus 20 equals a positive 13. And that's equation 3. You have 2x plus 1y, or just y, plus 5z equals 13. That's equation 3. Now we can take these equations. Now I would recommend rewriting them a little bit. Negative 2x plus y plus 5z equals 13, and 3x plus 4y minus 2z equals negative 14, and 5x plus 2y minus z equals 0. Now to solve this, you'd simply, I rearrange the equations first. I would just multiply the first equation by 3. And we get the following. And then I would multiply let's rewrite this as equation 1, 2, and 3. So I just multiplied equation 1 by 3 and got this equation. Now I'm going to multiply equation 2 by the integer 2. I'm going to leave some space down here. 3x plus 4y minus 2z equals negative 14 times 2. It's 6x plus 8y minus 4z equals negative 28. And you'll see that when you add these two equations, negative 6's cancel, and you're going to be left with 11y plus 11z equals 11, or y plus z equals 1, because you can divide through by 11. That's we'll call that equation 4. Now I'll multiply equation 1 by 5. Okay. And we're going to get negative 10x plus 5y plus 25z equals 65. And then we'll multiply equation 3 by 2, and we'll get 10x plus 4y minus 2z equals 0. I'm skipping some steps here. I'm just following along here. 2 times 5 is 10. 2 times 2 is 4. 2 times negative 2 is negative 1 is 2z. And if we cancel out the first two and add, if we add the two equations anyway, we'll be left with the following: 9y plus 23z equals 65. We're going to call that equation 5. Call it equation 5. Now take equation number 5, 9y plus 23z equals 65, and we're going to take equation 4 and multiply negative 9 by the equation 4, you get negative 9y minus 9z equals negative 9. And the negative 9's will cancel, and the positive 9, negative 9, positive 9 cancels. And 23 minus 9 is 14z equals 65 minus 9 is 56. And we divide by 14. So z, I'll write it over here, z equals 4, which is what we had originally. We're just proving it. So we can plug that back into this equation here, z equals 4, and find y, and y equals therefore negative 3, and then we can take these two numbers, plug them back into here, and find that x equals 2. I'm not going to do the math, but if you do it, you'll see that it's true. And that's that. Thank you.